Hello, my name is Angelo and I'm a researcher at the IOTA Foundation. Today I want to share with you some insights about the work I do here. As basically all the researcher here, I'm working at the Coordicide. That's not a big surprise, I suppose. We are working really hard to let this fully decentralized version of the IOTA protocol come to life. Now, our researchers have so many different backgrounds. We have mathematicians, physicists, cryptographers, computer scientists, and that is really good because we can tackle Coordicide from so many different angles. To give you a more concrete example of what that means, we have divided the work in different groups. So we have the protocol group, the networking one, the FPC group, the DRNG group, auto-peering and mana, and also the prototype group, which you might know as the Gossamer group. Researchers with a more theoretical background study these topics from a more theoretical point of view, while some others, like myself for instance, help with simulations and prototyping. I have to say that having so much variety of skills is really awesome. It allows to progress faster, and I'm basically learning something new every day. So I'm personally part of the FPC, the RNG, auto-peering, mana, and also the Gossamer group. And in this video, I'm gonna talk a little bit about the work we are doing with FPC, the Fast Probablitisc Consensus protocol. If you haven't checked out our Coordicide website already, I recommend you to do so. There you could find useful information about what each module is about, as well as the updated Coordicide white paper, which describes in detail the approach we are taking, and also other relevant papers like the one of the Fast Probablitisc Consensus protocol. So first of all, why do we need a consensus protocol in the first place, right? I'm pretty sure you are already familiar with the concept of double spending, but let's refresh our memory. In this example, I have, for instance, 10 IOTA, and I would like to use them to buy something from Hans, let's say a book. So I send to Hans this 10 IOTA, and let's call this transaction A. But then, immediately after the transaction, I try to double spend the same 10 IOTA by sending them to Popov, for instance. This time, let's call this transaction B. Now, if the network accepts this last transaction over the first one, Hans would have sent me the book without actually getting paid. And we call this a conflict. So, to avoid this situation, we need a consensus mechanism so that the network can decide on the order of this conflicting transaction. Now, there are a lot of different consensus mechanisms out there already. We have a proof of work, we have a proof of authority, proof of stake, proof of space, and so on. They all have their advantages and disadvantages. So why aren't we using something that already exists, you might wonder? Well, we need something that can scale really well when considering, for instance, several of thousand or even million of nodes. And also we need something that is reasonably fast so that a final decision can be made in a matter of just a few seconds. And that's why we have designed the Fast Probablitisc Consensus protocol. FPC belongs to the binary voting protocols family, where you give an object to vote on as the input, and in return you get a Boolean result that could be true or false, or in our case, liked or disliked. And the core idea behind FPC is really well explained in these two following points. So if initially no significant majority of nodes prefer 1, then the final consensus should be 0 with high probability. And also, if initially a supermajority of nodes prefer 1, then the final consensus should be 1 with high probability. Which basically means that the network will like a conflicting transaction only if a very big portion of the nodes will like it. Let's remember that liking or disliking is a matter of being able to order the conflicting transaction. So which one happened first, basically. If the network sees them both, almost at the same time, there is no way it can prefer one over the other, obviously. So it will dislike them both, and that's completely okay. If instead a big portion of the network knows that transaction A happened first, then it will like A and dislike B. Maybe this will become clearer once I show you this little example. Transactions A and B are the conflicting transactions. They enter into the network, and then the gossip protocols takes care of propagating them all over the nodes. Now, first of all, this is our IOTA network. and we will need to set the parameters of FPC. So let's start with the A and B, which defines the limits of the threshold for the first round. It kind of defines our significant majority. Let's set A and B so that this range is between 0.65 and 0.75. And then we have beta, which defines instead the threshold for the subsequent rounds. It can range from 0 to 0.5, and the closer is to 0.5, the less the randomness will play a role. So let's set it to something in between, like 0.3. Then we have M, which is the cool-off period. For this example, we can skip that and set it to 0. L instead is the number of consecutive rounds with the same opinion after which it becomes final for one node. Let's have this set to 3. And finally, K is the quorum size, basically the number of nodes we are going to query at each round. And since we don't have the whole day here, let's go with something small, like 3. Now we're gonna look at the FPC protocol from the point of view of this particular node. And we're gonna start voting for transaction A. Remember the one that we used to send 10 IOTAs to Hans. We will start, of course, with the first round. And our node starts querying 3 randomly chosen nodes, asking for their opinions, and it will get back their opinion. Then our node will need to calculate this variable called IOTA that basically calculates the average of the received opinion. So in this case, we got 2 likes and 1 dislike, and we average over the total number of nodes that we have queried, 3. So our IOTA in this round is going to be equal to 0.67. Then a new random number will come along. Now, FPC works in different rounds, and for each round it's going to use a different random number. This random number can come from different generators, right? It can come from a trusted random number generator, or in the Coordicide case, it will come from a distributed random number generator. But the important thing now is that we will get this new random that concludes the current FPC round. And in this case, since this is the first round, the random number will be inside the initial interval that goes from A to B, so 0.65 and 0.75, and in this case we have 0.66. So after we received a new random number, we have to compare our IOTA value with the random number just received. And in this case, we see that our IOTA is greater. So whenever we have our IOTA greater or equal with respect to the threshold, we set the status of the particular transaction to like. And we also keep this information, this status, in our history of opinions, because we are going to use it then to check if we have reached L consecutive rounds with the same opinion to finalize our FPC vote. Now, for the second round, again, our node is going to select and query 3 randomly chosen nodes, and we are going to get back their opinion. And we are going to again calculate our IOTA value, which in this case is the same as before, 0.67. And then we are going to wait for the new random number. And in this case, since this is a subsequent round, so all the subsequent round after the first round are going to use beta, more specifically the interval between beta and 1 minus beta, for the random number. And in this case, we have 0.47. So we are going to evaluate and compare whether our IOTA is greater than the random threshold that we received. And it is also in this case, so we are going to again assign for this round a like status to the transaction A. And we're going to keep this information in our history. And then for the third round, we're going to again start querying 3 randomly chosen nodes. We are going to get back their opinion. In this case, we are going to get all likes. So our IOTA in this case will be equal to 1. We are going to wait for the new random number to come along. In this case, it's going to be 0.55. we are gonna compare our IOTA to the random threshold, and we are gonna assign again a like status. And careful now, we have 3 consecutive liked, so we can finalize our transaction as liked. And obviously also all the other nodes are going to be running FPC for this particular transaction, and they will eventually get to the same conclusion as our node. And they will finalize the transaction A as a liked transaction. Now let's, for instance, consider instead the case of the transaction B, the conflicting one with A, you remember? Now, again, our node is going to randomly query three nodes and is going to get their opinion back. It's going to then calculate the IOTA variable, which in this case is going to be 0.33. This is a first round, so the random number will be between A and B. In this case, 0.68. We are going to compare our IOTA to the random threshold, which in this case is smaller than the threshold. So we are going to dislike this transaction, and we are going to keep in memory in our history this disliked status. For the second round, again, we are going to query other 3 randomly chosen nodes. We are going to get back their opinion. Then we are going to calculate our IOTA. In this case, it's going to be 0.33. We are going to wait for a new random number to come. In this case, it's the second round, right? So we're going to use beta here. The random number is 0.38. We are going to evaluate IOTA against this random threshold. Is again smaller than our threshold, so we are going to assign another dislike to this round, and we are going to keep this status in memory. For the third round, we are going to again query other 3 randomly chosen nodes. We're going to get back their opinion, and then we're going to evaluate our IOTA, which in this case is going to be 0. We're going to wait for the new random number to come, which in this case is 0.39. And obviously 0 is smaller than 0.39, so we are going to assign again a dislike status for this particular round. And now you can see that we got 3 consecutive dislike for this transaction, so we can finalize the opinion for this transaction and set it to dislike. And also all the other nodes are going to do the same protocol, so they will eventually dislike this transaction as well. Okay guys, I hope this example gave you a better understanding of how FPC works, even if I remove some of the details in order to keep it simple. If you are interested in all of its specifics, you can check out the paper, or if you prefer a more practical approach, as typically I do, we have released the source code of our FPC simulator, where you can play with different parameters, as well as simulate some attacks, and check how FPC reacts in those conditions. We also have implemented FPC in Goshimer, although it's not yet integrated with the master branch. You are very welcome to check that out as well. I'm actually working right now on its integration with the next release of Goshimer. Hope you guys enjoyed this short video. Till the next one.